Good afternoon, everyone. With immense enthusiasm and a deep sense of purpose, I welcome you all, our esteemed guests, students, and organizers to Pels Day 2025, proudly organized by IEEE Power Electronics Society, VIT Vellore chapter. Today isn't just a day on the calendar, it's a global celebration of innovation, sustainability, and the transformative power of technology. It is a moment to pause and reflect on how power electronics is driving us towards a smarter and more sustainable and net zero future. This year's theme, Designing the Future Smart Power Electronics for a Net Zero World, sets a tone for what lies ahead in our journey of progress. The call for net zero emissions is no longer just a global ambition, it is a necessity. And power electronics is the bridge that connects innovation to sustainability. Let us celebrate the vision, the progress, and the people who are making this change happen. You might wonder why Pell's Day? Like, why dedicate an entire day to power electronics? Pell's Day is observed globally to commemorate the formation of IEEE Power Electronics Society and to highlight the field's significance in our modern lives. From the electric vehicles we draw, like from the electric vehicles, electric cars we drive, to renewable energy powering our homes, to the smart devices in our pockets, power electronics is everywhere. It's the silent enabler of progress. Pairs Day is about recognizing the dedication of engineers, researchers, students, and technologists who work behind the scenes to make power cleaner and system more efficient and, more importantly, future more sustainable. It is a celebration of curiosity, creativity, and engineering excellence. Let's take a step back and understand the platform that brings us together. The Institute of Electrical and Electronics Engineers is the world's largest technical professional organization with over 4 lakh members in more than 160 countries. IEEE is a beacon of technological innovations. It nurtures the growth of young minds, fuels research, and connects engineers from every corner of the world. It empowers students to move from ideas to impactful innovations and from classrooms to cutting edge labs. Through conferences, journals, technical standards, and professional networks, IEEE plays a crucial role in shaping the technologies that shape our world. And as its core lies in beautiful mission, advancing technology for humanity. Now let's zoom in on the heart of today's celebration, IEEE Power Electronics Society, which focuses on one of the most exciting and impactful areas of engineering, efficient power and conversion and control. Power electronics allows us to harness energy from renewable sources, convert it to usable forms, and deliver it efficiently to homes, vehicles, and industries. It's at the core of technologies like solar and wind energy systems, smart vehicles, smart grids, then battery management systems. IEEE Pels provide a vibrant platform for engineers, students to collaborate, learn, and to contribute technological advancements. It is where theory meets practice and vision meets execution. Here at VIT Vellore, the IEEE Pels student chapter is more than just a club. It is a community of change makers. Let me take you through some of our initiatives. We conduct workshops, seminars, which are led by experts on trending topics like power converters, renewable energy systems, electric vehicles, then VLSI design, and more. These events give students real world exposure and technical depth. As we must know, innovation is best when it's applied. our hackathons and project showcase and challenge students to ensure that they grow in their career. And when we are talking about our club, we should also talk about our collaborations with companies like MathWorks and Chart that helps us bridge the gap between academics and industry. Through guest lectures, internship, and mentorship, student gets valuable insights. Every session, every activity is designed to shape tomorrow's engineers and innovators. When we talk about legacy, we don't just refer to years gone by. We talk about values, vision, and ripple effect of every project, every workshop, every idea nurtured within our chapter. Over the span of 2 years, IEEE Pels VIT has built a culture of excellence. We have witnessed ideas born in our midst grow into national level innovations. We have seen students transform into professionals who are now contributing to companies and leading various research work. But why but what truly sets us apart in our spirit of collaboration? The belief that every student, every volunteer, every mentor brings something valuable to the table. As we grow, it's important to have a vision that fills our mission. Our chairperson, Advik Vijay, beautifully articulates this through his words. Together we progress, together we innovate for the future. It's this spirit of teamwork, innovation, and learning that drives everything we do. As we gear up for upcoming conferences, hackathons, and industrial partnerships, our chapter is committed to staying at the cutting edge of power electronics. So, where do we go from here? We are not just preparing for careers. We are preparing to solve some of the biggest challenges of our generation: climate change, energy scarcity, smart mobility, sustainable development, with initiatives like upcoming research conferences, interdisciplinary hackathons, startup collaborations in clean tech and embedded systems, global networking opportunities through IEEE. We are setting the stage for tomorrow. As students, let's stay curious. As engineers, let's stay committed. And as a chapter, let's stay united. Now, before we move ahead and invite our distinguished speaker, let us just take a short yet powerful visual journey. We are now about to present a specially curated video that embodies the energy, innovation, and impact of IEEE Pels, both at global level and right here at VIT Vellore. This video is tribute to every small effort, every groundbreaking idea, and every member who makes this chapter so vibrant. Sit back, relax, and let the visuals speak for themselves.
Good afternoon to everyone. On behalf of IEEE Power Electronics Society, VIT Vellore, it is both an honor and a privilege to welcome each and every one of you on this very special occasion, a very special celebration. Today is just more than an event that marks on our calendars. It is a moment to pause, reflect, and celebrate the progress we've made in the field of power electronics, a field that silently powers so much of the world around us, from the smallest embedded systems to the vast energy networks that keeps the city alive. Power Electronic Society is about recognizing the thinkers, the builders, and the change makers. It's a chance for us to step back from our routines and reflect on what we are and appreciate the progress we've made so far. It is an invisible engine in our modern life. And what better way to celebrate the spirit of learning by somebody who truly understands it and somebody who truly embodies it? Today is made more meaningful by the presence of a very special guest, Professor Pallavi Bharadwaj. Dr. Pallavi Bharadwaj is not only driven by innovation but by purpose. The purpose of solving real world energy challenges, of making clean energy easily accessible, efficient, and reliable for all. And that clarity of purpose is reflected in depth and in the impact of her work. The key areas of expertise that span across most pressing challenges and prominent domains in today's energy transition are photovoltaic power conversion, designing systems that are fault tolerant, shade resistant, and ensuring high performance even in less than ideal conditions. In a world that is rapidly transitioning towards solar energy, these innovations help ensure the reliability and consistency even when nature is unpredictable. Transportation electrification. Working on fast EV chargers, battery lifetime expansions, as electrical engineers, electric mobility becomes a new normal. This research helps charging faster, safer, and more efficient, something all of us as future users and engineers can directly relate to. Green energy storage, where she's developing data driven models to integrate systems like hydrogen into our energy mix, moving beyond lithium ion towards a cleaner and a smarter solution. And finally, the ultimate goal, net zero transition, optimizing multi energy systems so that power networks are not only clean but also well balanced and future proofed. Each of these isn't just a pillar of isolation. Together, they form a vision, a smart, integrated, low carbon energy future. At IIT Gandhinagar, Professor Pallavi is currently setting up the Smart Power Electronics Lab, a cutting edge research space that aims to be at the intersection of power conversion, system intelligence, and energy sustainability. She brings together strong technical skills with practical thinking, something we as aspiring engineers can truly learn from. Professor Pallavi, we are incredibly grateful to have you here. Your presence today brings us immense value to this celebration, not only just through the knowledge, but through the mindset you represent. We are kindly waiting for Miss Professor Pallavi to speak up as she has not yet joined the meeting. So please pay patience and acknowledge the presence. Thank you. And also
May I
now a
kindly
small
request?
announcement has to be made.
Yeah,
Please listen and cooperate. Thank you.
yeah. Thank you, Jeevan. May I kindly request all the attendees to turn on their video cameras and ensure that the official background, which was sent to you by email, it should ensure that it is applied. Your cooperation adds to decorum and uniformity of our club. Uh, so, if anyone is facing problem regarding the background, you can just tell me, or else I will explain you. Um Try joining with your laptop so that it's easier for you to apply your background. Just go on the more, which will be given somewhere on your screen. It is denoted by three dots. And when you go over there, you will get an option of background and effects. There you will get to know there you will get to know, like, there are so many backgrounds, but you have to apply this background which is applied by all of our members. And it shows our uniformity, right? So yes, you can apply that background. First it should be like it should be saved in your desktop, so that you can see that background and just go on more, like there will be some icon of image, and plus will be there. So just go on that icon and select the image, and then your background is applied. So I request you all to just apply the background and switch on your cameras. Thank you.
Thank you all for cooperating, and now the wait has been done. Professor Pallavi, we are incredibly grateful to have you with us. Your presence not only brings us value to this celebration, only through your knowledge, through your mindset you represent. We are looking forward to the session with you with great anticipation. I speak on behalf of everyone when I say thank you for being here and for being the kind of engineer, educator, and visionary we all aspire to become. With great warmth and respect, I invite you to begin today's seminar. Ladies and gentlemen, please join me in giving a heartful welcome to Professor Pallavi Bharadwaj. Yes, ma'am,
Thank
you
you so much.
can please continue.
All right. I hope I'm visible. My screen is visible. So I'll just start with the presentation.
Yes, ma'am.
All good? Yes, you can see me. You can see my slides. You can hear me. Yes?
Yes, ma'am.
Okay, perfect. So, first of all, thank you so much for bringing me in to interact with all you folks. I am very, very happy to be here today. One thing I must say before I start this session is that students are incredibly a powerful force for the country and for the world. And if through this session you learn something, I hope you will actually use it to make the world a better place. So let's move forward with the talk. I would try to wrap this up in 40 minutes or so, and then we can open this up for Q&A. Okay. So let us begin. So the topic was very well chosen by the organizers, and it is very much in line with the kind of work we do here at IIT Gandhinagar. So smart power electronics is a branch of power electronics where we also embed data-driven technologies and take intelligent decision systems core of power electronics plus a layer of intelligence around it with the power of data. So that is the idea. Okay. So today I will be sharing how can power electronics help with net zero transition. Can anybody here tell me what is net zero? Anybody? You can share, you can put it in the chat if you want. What do you mean by net zero? I'm sure you know this. Zero carbon footprint. Generation equal to consumption. Energy consumed is equal to energy generated. Net zero transition refers to the global shift needed to achieve net zero. Yeah, so some of you are in thinking in the right direction. Net zero essentially means that whatever resource you use to generate power, the idea is you, yeah, Sugan, you're right, get zero carbon emission out of it. Okay, even if you are generating carbon through one way, another way you are offsetting it. For example, if you are producing electricity with fossil fuels, you're planting more trees, so somehow you are balancing it, huh? But the best way is actually to use resources which don't use or don't generate carbon emission in the atmosphere. Okay, so that's what net zero means, that you are net carbon neutral. You're not contributing to more emissions on the planet. Okay, we will understand why is that important during this lecture and how power electronics can help us achieve that. Okay, So if you are not interested in this topic, you can log off right now. I will not mind. But I wanted to give a brief overview of what the talk is all about before we actually start. Okay, very good. Yeah, I can see a
Everybody
lot of you are
here is from
participating in the
electrical
chat.
background, ma'am.
What's
So we
that?
all are we all are from electrical background. We all are enthusiastic about power electronics.
Ah,
I don't think
wonderful.
anybody would dare to leave.
Dare to leave. That's a strong choice of word, but nice. All right, perfect. So let me then tell you a little bit about myself. So I started my journey like all of you with my bachelor's in engineering in Delhi, and that was in 2012. Then in 2014, I graduated from my master's in Bangalore, ISC. I really fell into love with research, and I started my PhD the same year. And 2019 I graduated. During the end of my PhD, I became a Fulbright fellow, and I went uh, to Northeastern University in Boston. I think one of your faculty is also was also in the same lab. That's how we are connected. So yeah, after spending some time in Boston, I was offered a postdoc fellowship. Yeah, I can see Dr. Albert there. Hi, how are you?
Thank you for coming.
Wonderful.
Thank you, ma'am.
Wonderful, yeah. So we shared the same lab, not at the same time, of course, but our professor connected us, Professor Brad Lehman in Boston. So after spending 6 months in Brad's lab, I was offered a postdoc by his professor. Maria Illich was Brad's professor at some point. So she was working in MIT. So I did my postdoc at MIT for 2 years after that. And then towards the end of my postdoc, I was offered a faculty position in Denmark in Aalborg University. But that time, after having lived so long abroad, like 4 or 5 years, I realized that I want to come back to India because I really wanted to work for Indian research. I was always very passionate about our country. So the first IIT that gave me offer was Gandhinagar. After that, many of them gave me offer. But when I visited here, I encourage all of you to come and visit us. It is a very beautiful campus on the banks of Sabarmati River in Gujarat. So I really love this campus. So I joined here 2.5 years ago now, and I have started a lab called Smart Power Electronics Lab, and it is doing very well. So coming back to the topic today, why do we need renewable energy, and why it is required in today's age and time? When the climate changes, now it is already hitting 1.5 2 degrees Celsius, it becomes inhabitable for us to live on Earth, right? So severe symptoms of this we see, like storms, drought, fire, then floods, rising sea level. This picture on the right, they would always show us in Boston and say, MIT will not exist after some time if we continue the climate change the way it is happening. So it is a big issue. And but why is this happening? Why these severe atmospheric events are occurring? So if you notice, the carbon levels in the atmosphere, they are really rising at a alarming pace. From 1950 to today, in 75 years, this pace is unprecedented, right? And what has caused this? It is the industrial revolution, the burning of fossil fuels, accelerated burning and use of fossil fuels. So who is causing this carbon dioxide? The biggest culprits are us electrical engineers, because we have shown the world how to generate electricity with fossil fuels, right? So in India, in fact, the largest consumption of electricity happens. In fact, the electricity is produced mainly from coal, which causes a lot of carbon emission. Similarly, other industries like steel and cement, they are also responsible for carbon. But transportation, if you look, that is the third largest carbon emitter, huh? Which has trucks, two-wheelers, three-wheelers, cars, etc. Because it is using petrol, diesel, all these fossil fuels, right? In fact, buildings like residential, commercial, or agriculture, these things also cause a lot of fossil fuel emissions. So we have to be a little bit careful in using our energy needs. if you compare how the timeline has varied in terms of world electricity demand, we can see that in 2019, this is the year I finished my PhD, it was at a certain level. Then in the COVID year, that was the only year when the actual demand of electricity came down, not just in India, but across the world, in China, in US, in Europe, etc. But again, when the COVID ended, this started rising up, huh? And then it stabilized, and it is still rising up to today also, right? So there is no point of saying that we will cut our electricity demand, because the world is growing, India is growing, our energy needs are going to simply grow. There are no two ways about it. But we can still think about, how can we make the energy generation better? Can we make it more green? So the answer is yes, and I'm sure most of you are aware you have such amazing faculty who also work in similar area. Is the renewable energy sources. So if you look like photovoltaic, using the sunlight to generate electricity, in terms of centralized power plants like huge solar parks, if you see, those are centralized or utility scale. Then there is distributed, like rooftop. In your houses you may have solar panels, right? And then there could be onshore wind, offshore wind, so on the coast or off the coast, like that. Then hydropower, using the run of river, etc. You are able to generate electricity, or bioenergy, geothermal, etc. So if you see, throughout the world, the share of renewable energy in the energy mix has drastically increased. It has nearly become three times what it was in 2017, right? So what does that mean? That the world is actually going towards renewable energy in a big way. So we are also heading as a country in that direction, which is quite promising. And so if we look at how has the change happened in terms of renewable energy, fossil fuel energy, etc., so you can see renewable sources, they have increased. The net change is positive for solar. For wind, it is also positive, bioenergy positive, hydro positive, but there is no increase in coal. In fact, people are going to get less and less fossil fuel based energy. Gas is also going towards negative. Nuclear, not so much. Oil also going towards negative. What does this mean? That the world is actually moving towards more renewable energy in their energy mix. So, in India, especially if you look at our map, right, we can see that so much solar irradiance is possible, especially where you are, in this part of India, where I am, this part of India. We are so blessed with such huge resource called sun. You know, when I was studying in India, I never appreciated sun. But then I went to Boston, and I'm sure Dr. Albert would agree with me that in Boston you hardly get sunlight. In fact, people become depressed. Similarly, in Denmark, you hardly get sunlight. So the appreciation of sunlight comes when you come back from abroad. And then we realize that India, we are so blessed with such great sun power. So why not use it, right? So it is projected that by 2040 we will meet the coal power midway. So it is not possible to make coal power plants for zero production, because you know every power plant has 5,000 crore, that kind of investment. And suddenly you can't say I will put locks on all and finish using coal power, because a lot of monetary investment has gone into making those power plants. Correct? So we can't say we will phase them out completely right now, but slowly and gradually we want to phase it out. So it is anticipated we are somewhere here, but ultimately throughout the world we will remove our fossil fuel based electricity generation, and by 2040 we plan to meet it midway, 50%, like that, you know. In fact, as a country, so this is from an environmental perspective, but we as a country, you know, for our energy security also, this is most needed, isn't it? See, if one day we import coal, you know, from so many countries, let's say Indonesia says I will not export coal to India, then who will make our electricity? We don't have coal anymore, isn't it? Let's say another country says we will not do this, we will not do that, we will not give you any fossil fuel, will not send you crude oil. Our energy security is at risk, correct? So therefore, it is very, very important for us, for our own energy security, to generate power locally without depending on imports. Like we imported 11 trillion worth of oil in the last financial year. So this is a very risky situation. So what we want to do, we want to make sure that we generate our power locally so that we are energy reliant, right? If we look at our present electrification scenario in terms of net zero, which is the main part of this talk, right? We have about 426 gigawatts coming as a overall grid, total capacity of India, generation capacity, and renewable energy is about 41%, which is a very good number, right? And if you look at fossil fuels, we added some, but we added a lot of non-fossil fuel. So only 1.6 gigawatts we added in terms of fossil fuel in the last financial year, but 8.2 gigawatts we added renewable energy, which is so good, right? Which has major solar and then little bit of wind and then bio and then hydro, etc. But solar, if you look at it, it is coming up in a big way in our country. In fact, the government plans to make it 500 gigawatt by 2030, which is just in next 5 years. So the time is really running. A lot of good technology is needed to make this happen. In fact, I remember when I was a PhD student and I went abroad. So some students from China and Vietnam, they used to ask me that why India is not becoming 100% electrified even after so many years of independence. But I'm happy to share today that we have actually become 100% electrified in the past few years. In fact, last year's data, they said that more than 20 hours we have electricity in rural India and more than 23.8 hours we have electricity in urban India, which is such a great feat. Even though the power quality may not be as high, for which we have to study power electronics. That is the motivation. So if we have to go solar or go renewable in terms of wind, etc., we need to have some kind of power electronics in between, right? Why do we need power electronics? Can anybody share in the chat why power electronics is needed to interface solar or any kind of renewable energy to the grid?
They could act as connecting systems, right, ma'am? Like between the grid and the windmills or solar panels present there to harness energy.
Right. So the thing is that solar panels produce DC power, you know Yeah, for control, conditioning, and conversion, we need power electronics. The main reason is that this power from sun is direct current. It is DC. But all our power grid is what? It's AC, correct? It is alternating current. So we have to first convert this DC power to AC power. That is what we have to do. Now to do this, we have to put what kind of a converter? Rectifier or inverter? Tell me. DC to AC, what is that called? You can put in the chat or you can speak up. We need an inverter. Yes, very good. Very good. Yes, we need inverter. Now this inverter can also help us control how much power we want to take out, in the sense that can we operate at the maximum possible power, that is called as MPPT, maximum power point tracking. Next is, if there is any shade or any fault, can you detect it and still generate energy from sun? Yes, that is called as fault diagnosis. Then the sun is not very predictable, isn't it? You can't tell sun tomorrow you shine for 3 hours, or day after you shine for 12 hours. You can't say this to sun, right? Sun is not in our control. So forecasting how much power based on the weather data, let's say you say that, okay, I anticipate that so much power will come from my solar panels in this part of the country, in this month, in this weather, in this time. So that is called as predicting or mission profiling the electricity coming from the solar panels. Okay, so this is one challenge that you can do research on and help the community. The other challenge which comes from the power electronics is that power electronics is like a middleman, right? So it is taking energy from panel, solar panel, giving it to the grid. So what do you think? In between, it should take some energy like losses, or it should have zero losses? What do you think? This middleman should do some losses, or it should be zero loss? Minimal losses, right? Very good, Shivam. Yes, zero. Good, 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 Jeevan. So definitely, yes, yes, most of you are writing. Minimal. But is it practical to get zero? Some losses are there practically. Yes, very good, Manish. So some losses will certainly be there, but our job as power electronics engineers is to make sure that this is maximum, the efficiency is maximum, and the loss is minimum. So that is one task as power electronic designers. Second is, because there are some losses, it gets dissipated. If the dissipated energy is less compared to what is generated inside, what can happen? I'll ask again. Dissipated energy is less and heat generated from losses is more. Then what will happen? Wear and tear. In worse situations, what can happen? Breakdown. Yeah, it can catch fire, it can go into thermal runaway, etc. Right, very good. So in that case, reliability comes into picture. We have to make sure systems and components do not break down. है ना? So safety and monitoring it, monitoring the temperature, monitoring the voltages, currents, everything is very important. Okay, and then communicating with the rest of the system. So this middleman has to tell how much power is coming from PV, how much I'm sending to the grid. So all this this is the interface, right? The interface has to communicate. So these are the challenges from power electronics side. Now grid side also has many challenges, right? Grid, you have to make sure you maintain the power quality. What are the three important aspects to synchronize with the grid? If you have to make any connection with the grid, you have to take care of a few things. What are those things, do you think? Phase angle, yes, Shivam. Frequency, voltage, phase, Manish. Yes, very good. So these are the three things that we have to make sure in an AC system: frequency, voltage, and phase. This is mandatory for us to connect any system to the grid. Okay. So to do that, we have to maintain a certain power quality. We have to make sure harmonics, because of power electronics, because of switching, are not very, very high. They have to be under certain limit. If there is some fault, we have to make sure that we disconnect. And sometimes if it is a transient fault, we stay connected. It is called as ride through. So all these things we have to ensure from the grid point of view: maintain the voltage, maintain the frequency, maintain the power quality, etc. Okay. So that is where the role of power electronics is very important. In fact, it is said that 70% of electrical energy in USA alone transfers through power electronics. And this is going to become 100%. Why do you think power electronics is coming more and more into play? What has changed that it is going from 70 to 100%? Why power electronics is becoming more and more important in today's time? Least losses compared to mechanical transfer, okay. Population demand. Okay, no, what has changed? So see, losses we should have ensured from the very beginning, na? Ah, very good, Amitesh. So this is the reason. See, renewable energy requires power electronics for interfacing. Electric vehicles require power electronics for charging the cars, right? So power electronics is and quality of power, because both renewable energy and electric vehicles are definitely increasing their penetration into our grids. So we need more and more power electronic converters to control the power, maintain the power quality, etc. Okay, yeah, that is correct. So how did power electronics start? Way back in 1902, some experimentalists like Peter and Cooper Hewitt, these people did something called as mercury arc rectifier, which showed that somehow you are able to get only DC current in a vacuum tube. Then they started the discovery of transistors in Bell Laboratories in 1947, which means at will you can turn on and off a trans resistor. So by changing what you apply on its gate through the drain and source, you are able to see how much current passes. So they started. So BJTs came, then MOSFETs came, then IGBT. So many devices came, which made it easier and easier. But now, if you look at power electronics, it is in all the fields from electric vehicles to renewable energy to your homes. In fact, today they were repairing the elevator in our campus and they opened the door. It was all power electronics, right? So, everywhere you see power electronics now. Wireless charging of your phones, the charger in a laptop, the battery charging in an electric vehicle, the driving of the motor, it's all power electronics, right? So now more and more need of power electronics. In terms of PV, like we said, no, photovoltaics, how do we connect it to the grid? That can be done. So one, you can have DC to AC inverter, single stage, or you can have two stages. So first you can have a DC to DC converter, then you put a DC to AC converter. Why do you think this first DC to DC converter is used? Any ideas? Oh, MPPT, yes, Uma Maheshwari, that's a good idea. But there is a even more basic reason than this. Boost, yes, very good, very good. So because PV panel voltages may not match what your grid requires, so you do some kind of voltage change, okay, to match your grid voltage. So first you step it up, you do MPPT at the same time, and then you do DC to AC inversion and you send to the grid with the necessary isolation, okay. So this is a low frequency or a grid frequency 50 hertz transformer. The problem with this is that it is huge, it is bulky. Ah, then another option is to make it less bulky, you make it high frequency transformer. See, if I tell you for a filter, omega L is the impedance. So if I increase the frequency, what will happen to the inductor size? Would it increase or decrease? Reduce, yes, very good. You have trained your students very well. Congratulations to all the faculty at VIT. Yes. So the size should reduce because then omega L, if omega increases, then L can go down. So the size of L can go down. Yes. Similarly with magnetics transformers, if you increase the frequency, the size can go down. So rather than having the isolation, first of all, why do you need isolation? To connect PV, why do you think isolation is required to the grid? What is the use of isolation? Anybody? Isolate load and source. Okay, why? Safety and protection, yes. So any fault from the grid side should not affect the PV, and any fault from the PV side should not affect the grid. So electrical isolation we provide. Magnetically the energy gets coupled. है ना? Yes, yes, very good. So to prevent fault transferring for safety and reliability. So isolation is required and it is mandatory also in many grid codes. Sometimes it may not be required. So in that case, you can directly have DC-DC and DC-AC and transfer power. But when it is required, you need either at low frequency, at high frequency. Okay. But if because you are doing high frequency, then you also have to do rectification because transformer can work with DC or AC. Transformer can work with AC only, yes. So you first convert this PV panel power to high frequency AC. Okay. You make it on and off like that. And then you rectify it and then you go into inversion. Okay. So next question that comes for us is how do we scale this. Scale as in your house, you may need just one panel, two panel, three panels, etc. But if you're talking about a big utility power plant with solar, then you may need multiple panels. So how do you convert this power into utility grade power or AC power with power electronics? There are many options. One is you put one inverter per panel. These are also called as micro inverters. Or you can have a two-stage system, one DC-DC for voltage step up and one DC-AC for inversion, right? But this is one power electronic converter per module. The problem with this, at low power it is okay, but at high power if we do this, this becomes very expensive, है ना? So then another option is, okay, you need MPPT. So for every single module, you put DC-DC and then multiple such panels, you put it together in series or parallel, and then you have one central inverter. It is less expensive than the first one, but the problem is that because you have just one inverter, if something goes wrong here, it can disable the power going from all of them. Okay, so reliability is an issue. Another option is that to save money, no need for DC-DC stages directly because they're all in series. So voltage step up is taken care of. So you directly put a series string inverter. Can anybody tell me what we will lose? We will gain money, right? But what we will lose if we do this? Any thoughts, any ideas? Yes, we will lose a lot of power because individual MPPT is not taken care of, isn't it? So this is the problem. So this will save you money, but performance you will lose, right? And then the next thing is a multi-string inverter, which means that multiple these things are there in like one string has a DC-DC converter, another string has a DC-DC converter, like that multiple strings, and then a centralized inverter. Okay, so this is better than just this, which has all of them put together, just one power electronic converter for inversion. Okay, this thing can at least give us better MPPT ability, but this is the most cost effective, right? Sabse sasta, the most cheap solution that you can find, but performance gets sacrificed. But because at this kind of power level, this is the only thing which scales, that is, money is important. If you have to translate any technology, you have to take care of money, right? So this is what we find usually in power plants. This is what we find usually in our houses, but this is the most optimal, either of these, okay, in terms of performance, but definitely it can be more expensive. But this is the middle ground. You have best of both worlds. You save some money also, at the same time you are able to, this you generally find in industries, decent performance. Okay, scaling with power level, it's an important decision as an engineer. Then what else? Power electronics, what we have to take care in terms of, so power electronics is not just the hardware, right? With transformer placement and all, number of inverters, we saw hardware optimization. The other thing is control or the software optimization of power electronics. Huh? So like we discussed in the beginning slides, depending upon the ambient conditions, we try to find the maximum power. So MPPT. We do islanding also. Islanding means, as the name suggests, if there is a fault at the grid, you detect it and you island your system. What does that mean? You say, I don't want to do anything with the grid, I will generate my own power. Okay, and then anti-islanding is opposite of that. So if the fault is cleared, you want to connect back to the grid. So this connection disconnection, you need protection in place. It's called anti-islanding protection. Then you also monitor it, right? If there is any fault, you say how much power it will give me, all that you do. With grid, what all we did, we discussed, right? We did synchronization of what? Again, same question I asked some time back. Inverter with grid in terms of what parameters? What do you need to match? Voltage, frequency, and phase. Very good. Yes, very nice. So, and then DC link is very important. So, what we do, DC to AC, and then in between we have some conversion stages, because we have to step up the voltage and then we do inversion. So when we step up the voltage, we maintain this voltage at a certain level. It is called as DC link voltage control. Okay. At the same time, we make sure that we control how much power should go to the grid. See, sometimes it is possible that you are islanded from the grid. You are not connected with the grid. You are only serving, let's say, your local loads. Let's say I have a PV panel on my roof and only this room's loads I'm serving, like my AC, my lights, my computer. Okay. Let's say I'm feeling cold, I turn off the AC. So I don't need so much power. So ideally, what should happen? Should I increase or decrease the PV output? I'm turning off AC. What should I do with PV power? Increase or decrease? Decrease, right? Because AC load has gone out. So power should reduce. So by this control, by saying, okay, so should I operate on MPPT or not? I was operating on, no. Initially, I was operating on MPPT, but now my power has reduced. So I have to go to a lower current because voltage is same at the DC link. So current that I'm taking from the panel has to reduce, which will change the voltage of the PV panel also. So we have to make sure that the current and voltage is in my control as per my desire as a user. Okay. So all this has to be taken care of by power electronics. Okay. Similarly, you have to communicate with the rest of the system. You have to have some kind of intelligence in the system. So let's say if grid voltage is falling, you insert more what power? Real power or reactive power in a distribution? It depends on whether it is a distribution grid or a transmission grid. So depending on how is your how is your short circuit ratio, it could be either the real power or the reactive power. It is dependent. Yes. So to support the grid, if voltage is falling, frequency is falling, or reactive power is reducing, we do grid support. So by changing how my switches are turned on or off, I can increase decrease voltage, increase decrease frequency by pumping in more real power, etc. And or pump in more reactive power by keeping it more out of phase, like that. Okay. So these things we do. This we already discussed. See now, how is sun? Is this a continuous source or is it an intermittent source? Tell me. Intermittent, right? You can't tell sun that today no night for you. You have to shine 24 hours. Can you say that? No, you can't say. It is intermittent. है ना? So because of this stochasticity, you need some kind of energy storage in your system. This energy storage can be either in terms of what all? Tell me, what energy storage are you aware about? What energy storage sources are you aware about? Lithium ion batteries, okay. Battery energy storage system, redox flow batteries, okay, very good. Anything else that is coming up? Okay, solar thermal, okay. What is mother battery system? Supercapacitor is good for power, not for energy, okay. Sodium ion battery, okay. Anything else that is coming up in a big way now in India? Okay, molten salt, second life of batteries, okay. Other than batteries, let's see if somebody can tell me. Hydrogen, yes, very good. So hydrogen based fuel cells, yes, that's coming up in a big way in India. So that energy storage is also coming. Okay, good, good. So what else? if we move from renewable energy to EV, also we are not technically ready, isn't it? I mean, we are getting there. Like I said, why do we need EV? Because 80% of our oil imports are going into our transportation sector, right? So if we can generate electricity more renewably and then use them to charge electric vehicles, we can prevent so much cost of oil import. Ah, so by 2030, we want to get 5 crore EVs on road. Can you imagine so many? And 20 lakh charging stations are needed to support them. Okay. So what does this mean? That we need a lot of investment in terms of both capital investment and operating cost. The problem with these companies is that, yeah, more jobs, that's correct. The problem with these companies is that EV charging operators is that they don't have so much consumer base right now because it is a growing industry. The problem with consumers is that they have charging anxiety. They don't know if they take their car for a drive, they will find a charging station or not. It is getting better, especially in big cities like Ahmedabad, Pune, Bombay, Bangalore, Delhi. It is getting very good actually, but more needs to be there in all the cities, है ना? And yeah, range anxiety is there. If you want to go from Delhi to Bombay, you don't know whether you'll find charging station in between. So petrol pumps are everywhere, but do you get EV charging stations everywhere? You don't know. Even though Google now has on its maps, it can tell you, but still, there is still some anxiety that consumers have. Also, the time. Time is that petrol takes 10 minutes to fill up. Now, if you want to charge your EV, it can take a very long time, right? If it is level 1 charger. So people have these hesitancies to go towards EV. So we need to remove them and be ready. See, in 2022, when I returned to India, it was a very good year for EV because so many companies jumped into local manufacturing of EVs. Yeah, even though they were importing batteries, etc., but still more or less the ecosystem was forming. The same year, also we expanded the charging infrastructure, which can be on board, off board. You know, understand na? What is the difference between on board and off board? What is on board versus off board charger? On board means on the vehicle, off board means outside the vehicle. So, where do you think fast charging is possible? On board or off board? Fast charging is possible off board. Why do you say that? Why can't we do fast charging on board? Yeah, see, the thing is, if you want to fast charge a battery, you need to dump more power, more energy in less time, right? So, high power. To have a high power setup, you have to have a bulky huge charger which can handle that kind of power, correct? And therefore, because in the car you have space, weight, size constraints, etc., you can't do onboard charging. So off-board chargers are usually level 3 or fast charging. Then there are different classifications, whether it is unidirectional, bidirectional. What does that mean? In one way or in both the directions? Why do you need bidirectional charging, by the way? And there's a question also, why regenerative braking does not count. That is true for only on board, no? Regeneration means that using the mechanical energy, you convert back to electrical energy and charge the batteries. So then you need bidirectional, correct? But I'm asking for off board. Why do you need bidirectional? V2G, V2X, etc. So from vehicle is nothing but battery on wheels, right? So if the grid power is falling, you can pump it back. So that's why you need bidirectional. Okay, and then of course isolated, non-isolated, AC, DC, or both, which is called as universal. Wireless charging, if you have, is it inductive or capacitive, static or dynamic? Static means you have to stand the vehicle still, then only it can charge wirelessly. Or dynamic is while moving slowly on the road, let's say, can it also charge? So something like that. Okay. Yeah, battery charge cycle. We'll talk about all that, huh? Don't worry. So fast charging is coming up in a big way. But the problem with fast charging is that because you're dumping more energy in less time, you tend to heat up the battery. See, level 1 charging is 2-3 kilowatt. It can take 6 to 10 hours, like in your houses. Level 2 is 1 to 3 hours, so 6 to 7 kilowatt. It can typically, be used in like parking spaces for community, etc. But fast charging is typically dedicated chargers like Tesla superchargers or fast charging by Geo. There are so many places. So these companies, they have their dedicated fleet of fast chargers which are for their dedicated vehicles also. But the problem is that if you want to go 5 minutes charging, like that, then you're dumping so much energy in the battery in less time. So the problem is that it will heat up. So you need to have some kind of force cooling, etc. Otherwise, battery lifetime will be very, very less. Okay. And it can even go into thermal runaway and catch a fire. So it's a safety risk also. So you have to be careful while pushing the limit of fast charging. So typically also we see fast charging is done at DC and not at AC. The reason is that why would you want to waste power? Battery is DC, right? So if you are talking at that high power, you don't need multiple conversion stages. Directly you want to charge from a DC converter the battery. This, it can come from photovoltaic, so DC to DC conversion, like that, or it can be rectified through the grid and then DC DC converter for fast charging. Okay. So how do you charge? One way is constant voltage called CV charging. Other is constant current. Keep the current constant at the rated value and charge the battery. Then there are more optimized ways like constant current, constant voltage. For some time maintain constant current, for some time maintain constant voltage. Then there are some more very interesting ways coming, which is like you give multiple steps or you can give it pulses, both bidirectional. So it helps nice redistribution of lithium ions in the battery. Ah, so there are so many ways that you can charge it. Now, in fact, with the use of models, with the use of AI, you can find optimal charging algorithms for your system. Okay, for your battery type, for your application, etc. So, like I said, this charging optimization, especially for level 2, level 3, which is high power charging, it is coming up in a big way. Do you want to go with conventional CCCV kind of, or go with a model based approach for your technology? Which one should be better? That is something you can figure it out. Okay. Then there are some very interesting things coming up in this field which you can take up for research projects, etc. One is this V2G, which we just discussed. Unidirectional is V1G. Bidirectional becomes V2G. But battery cycling is a big issue for V2G. So because the cost is high, for batteries, replacing batteries, and their life cycles are limited. So you can say only 1,000 times it can charge and discharge. So if you do this V2G, then your cycle is compromised, right? So unless we have smart BMS to take care of the battery life, this becomes a limitation of this technology. And that's the reason it has not become commercially hit in India so far. Okay. Second is big opportunity coming up is energy markets application. What does that mean? Energy is a commodity that you buy and sell in the market, and you make money accordingly. For example, in the afternoon hours, sun power is plenty, so its cost goes low. But in the night, you have to store it in the battery and then sell, so the cost becomes high, right? Or it depends on summertime, peak AC loads are in the afternoon. That time the electricity becomes very expensive. So during peak hours, can you sell power and make money? So it's a very interesting area. You can, if you want to make a company, this is a growing area. Okay. Another very upcoming area is the second life. Somebody mentioned also in the beginning. So second life of battery, which means that you don't discard it after use, you restore it, you recycle it, reuse it to whatever extent possible, rather than directly disposing it or burning it, etc. So the reduction can happen. Yes, repurposing the battery. That's correct. So second lifetime applications are needed because see, when the battery capacity hits 80%, they say that you can't use it in your car. It is a thumb rule from EV industry. So 80% capacity means what? If it can go for 100 kilometer, it will only go to 80 kilometer now, roughly, right? So then it is not a problem in the house, right? So you can always repurpose it for your house energy storage system with solar panels, right? So instead of saying the battery is no good anymore, you give it a second life, like a house energy storage or a grid energy storage in stationary applications. That is possible. Okay. So this we were talking about, right? So this battery failure is a big issue. This fires is a big issue. So this happens when you abuse the battery in any way. So initially smoke comes and then it catches fire. So using the proper battery management systems, can you prevent this from happening? This is very important, right? So you take care of its safety, you prevent thermal runaway from happening by managing the temperatures, you take care of battery aging, you track its life cycles, you balance the cells well in series and parallel so that they don't overcharge or over discharge. As per the vehicle's needs, you charge the battery accordingly, maintain its states, charge, health, power, etc. How do we do that? We measure voltage, current, temperature, and then we estimate the internal states and we communicate it with the vehicle. Yeah. The idea is prevent its degradation, keep it safe, maximize its lifetime, its energy utilization by charging it properly. So many research avenues are coming up in this direction of renewable energy powered by power electronics. It is energy storage, like we discussed, solar PV, electric vehicles, green microgrids, electric aircrafts. See, so many times aircrafts have issues. Recently, also, there was a crash, right? Very unfortunate. So, more controllability can come if you have electric aircrafts. Okay, you can have more control over your system, and then of course second lifetime that we discussed in the end. So if I have to end this session, there is no better slide than this to summarize the whole work, which my lab works on here at IIT Gandhinagar. Spell is our name, Smart Power Electronics Lab. We work on solar, we work on hydrogen-based energy, we work on electric vehicles, battery life extension, grid forming, and we create a sheath or a layer of smartness using real-time data collected through our IoT and decision making through AI to make the whole system more efficient, cost effective, and long lasting. These are some of the references. Thank you. You can always connect to me by email or check if you need details about our research. You can check our lab website. Okay.
If you are with your permission, may I please deliver a vote of thanks to you,
Sure.
ma'am?
Please, please.
Yes. As we come to the close of this wonderful session, my dear audience, it is my heartfelt privilege to deliver the vote of thanks on behalf of IEEE Power Electronics VIT Vellore. First and foremost, I would like to express our sincere gratitude to our pillars of support, Dr. Albert Alexander and Dr. Chitra ma'am, for their constant guidance, leadership, and under your mentorship, IEEE Pels has grown not only as a chapter, but as a vibrant community of learning, innovation, and impact. Your beliefs in empowering students and your continuous encouragement has enabled us to host, present meets, and work tirelessly towards student development and student knowledge. And also, a special thanks to you, Pallavi ma'am, for taking time and effort to deliver such a meaningful and beautiful structured session. Your insights have truly enriched us. You're inspired not only undergraduate students, but also PhD scholars, aspiring professionals, and encouraging all of us to think critically, explore deeper, and keep learning. Lastly, to everyone attending, thank you for being a part of this journey. Before we conclude, I would kindly request all of you to follow IEEE Pels VIT Vellore on Instagram and LinkedIn as shown on the slides. Stay connected with us to keep in track with upcoming events and opportunities and stories that celebrate student excellence. Thank you once again all. We are looking forward to see you in future initiatives. Thank you very much, ma'am. Thank you much, sir. Thank you, Chitra ma'am, for being with us today.
Thank you. Thank you, Pallavi ma'am, for your acceptance. It is all.
Thank you so much, Dr. Chitra, Dr. Albert. Thank you so much. Good luck to all the students.
Cheer to VIT, ma'am. So, based upon your schedule, please plan a visit to VIT.
Sure, sure. And you please
Sure.
come to IIT Gandhinagar. We would
Okay.
love to receive you.
Thank you, ma'am. Thank you so much. Okay, we'll mail you the details. Thank you.
Definitely.
Thank
Take
you, ma'am.
care.
Thank you, ma'am.